In this white box, it doesn't look like very much. It is called a Stevenson screen, and inside there are our thermometers that we measure by hand. We have other Stevenson screens around the observatory which are doing continuous monitoring, and it's got these little holes in it, and that allows the air to flow through, but also to shade the thermometers so that we know that they are reading an accurate temperature. We've got dry bulb thermometers, we've got wet bulb thermometers, and the wet bulb has got like a piece of cloth wrapped around it that's wet all the time and allows the air to flow through it, and that kind of acts a bit like a body sweating really. We're looking at that evaporation as well, so that wet bulb reading. And then we look at the maximum and the minimum temperatures every day, and those are really, of course, very key to seeing whether records have been broken. So this is our international standard rain gauge, and it's got this windshield around it, and you'll find these across the world looking exactly the same, at the same height. So we have standard measurements across the whole world. And the windshield's really important because when it rains it's often really windy as well, so we're trying to protect the gauge from those gusts of wind so that we can actually capture the rain that's falling. We start off from this starting condition that's fed by the observations like the ones in this observatory, and that kind of creates like what the atmosphere is doing right now, and then we use the physics of atmospheric flow to work out how that's going to evolve in the future, and then that gives us like things like temperature and rainfall tomorrow, the day after tomorrow, and then that data is then fed into all of these different apps.